We continue our introduction to mathematical metaphysics by Christopher Langan. We define metaphysics as a logically idempotent metalinguistic identity of reality, which couples the two initial ingredients of awareness, perceptual reality, the basis of physics, and cognitive perceptual syntax, a formalization of mind. And today we understand syndiffeonesis. Syndiffeonesis can be intuitively understood as difference in sameness. It is what occurs when an observer simultaneously recognizes any set of discernible objects in juxtaposition to their logical complements, or when a thinker simultaneously recognizes a set of concepts or values as similar or congruent. It captures the relational structure of attribution in the conceptual aggregation of discernibles, describing the situation in which a set of discernible instances is recognized or defined through a common syntax through which they are aggregated. Syntax consists of structural and dynamical invariants, which support and constrain the language on all formal scales. They are distributed over the language intrinsically or by language users. The concept can be generalized to any attribute or structure shared by a set of instances to be identified through it. Accepting syntax is that part or aspect of the mechanical structure or programming of a computational automaton which enables it to accept or recognize input. The concept can be generalized to non-mechanistic transduction. The syndiffeonesis is this difference in sameness, and this property is broadly distributed. Whenever we have two discernible objects, then we have syndiffeonesis, and we have it to the extent that we see the objects together with their logical complements to say this is this situation as opposed to the logical opposite situation, or when we notice a relationship because of a similarity between set of discernible object concepts or values. So when we see commonality between any two things, we exhibit syndiffeonesis. So reality as a whole is a syndiffeonic relationship. It has the unity of being reality, and it has all the diffeonic aspect of all the instances of reality. So in mathematics, if we take a Cartesian space and we talk about the geometric points, we can talk about the points that are at the right of the origin. And in that way, we understand these points as opposed to the complement, which is the points at the left of the origin. And obviously, there is difference in sameness in these two logical complements because there's a whole structure of just reducing our universe to this line with an origin and points at the right and at the left. And only through this structure, which is a structural synesis, do we understand the difference between the points at the right and the points at the left. When we then assign the number line to this geometrical object, then we can notice that the points that correspond to the positive numbers are the same points that correspond to the points at the right. And so these concepts, these geometric concepts that are related to orientation and this valuation of the signs of the numbers represented on a line, they become similar and congruent. And so there is a difference in sameness in the sense that these points represent the same area on the line when the line is modeled in two different ways, in a way where there is only location compared to the origin, or in a way where each point becomes a representation of a number. So here we talk about synesis in the level of the output of concepts that are defined in two different models of the line, with an origin and points at the right and at the left. We have difference in sameness in the concept of the points at the right are the complement topologically to the point at the left. In another way, the points at the right are logically complemented by the absence of the points at the right. In that way, we have the synesis, which is the structure of the defining space where we can select point or we can make points appear and become discernibles as specific points. And there's a logical complement between attributing the existence of this point on this line through this model or not attributing the existence of this point. And so more directly, the logical complement of the points at the right is the absence of the points at the right. And the structure that allows us to consider the presence or absence of these points at the right allows us to discern the specific situation that we are in. If we are not able to conceive of the absence of the points at the right, then we are not able to conceive that there are points at the right of the origin in our model. We need to have a structure that allows to make an attribution of information within a structure. And so when we present a situation, we have difference in sameness in the sense that there is a diffeonic attribution of a specific situation in the structure that offered a choice between different possibilities. If there is no choice, no structure to point towards specific information, then the information is just void. The structure doesn't provide any room to make the information exist as something that offers logical complements and so that offer specific perception. The presence of this situation versus the absence of this situation. The syntax of the line with the origin and the potential points on this line is a common syntax that defines the points on the line. So not only are they recognized through the common syntax, but they are indeed defined through the common syntax. This common syntax becomes the condition of recognition, but also the condition of generation of those points. So we see that synesis has both a passive and active role in defining information, in defining meaning within reality. Because reality is a language, it needs to have this common syntax that allows the different components of reality to read and write within reality, to read and write the true information that exists within the range of possible information. Because there's a structure of possible structured information, then there's a possibility for the components to define a particular information within that range of possibilities, and then to have the information of the structure of the valid information within reality and the rules of evolution, and the structure of these rules of evolution. And only because there would be this common syntax can these components of reality write within reality, i.e. within something that is recognized by reality, that is recognized by the reality syntax. And if there would not be recognized by reality syntax, then these components would not be real, would not participate in the definition of reality. So there's this common syntax that constrains the language overall to create this possibility of communication between the different components of that language. And this syntax has to be distributed intrinsically, meaning the language is just defined in such a way that it creates this possibility to have these distinctions, and so to have this common structure that allows to read any value within those distinctions. Or it can be defined by the users of that language, which read and write, and can also influence the kind of invariants that are getting distributed within realities, to have an evolving language, a language with some configurative freedom, where the syntax is not only defined intrinsically, but also by the language users of that syntax. This syntax that can be understood as this common syntax of reality as a whole, understood as a language in a very formal way, in the same way as we would think of the common syntax of a programming language such as C++ or Python, where you would have the intrinsic syntax of the language, as well as all the syntax created by language users, this general concept of syntax can also be understood as the substructures and the sub-attributes that emerge within the global, broader syntax. And so you identify any set of instances within the broader language can be understood within syntax. And so this is the extension of the concept of syntax, where syntax applies more broadly to any attribute or structure. And so when we think of the syntax of perception, when we think of the Kantian syntax of perception, where perception is understood as being something that relies on the syntax of space and time, of the syntax of logic, of the categories of the understanding, then these also become subsyntax of the reality, and these are the sort of structures of information, structures of discernible objects that become embedded within this concept of syntax. And so within this more specific understanding of syntax, not the broad syntax of the language, but specific structures or attributes within that language, we also identify accepting syntax, which is a syntax that accepts or recognizes input. So mechanically, if you want to go up to the upper floor, there's a mechanical input that allows you to press the button of the elevator to create this situation where the system of the elevator will accept your input as the input that allows you to go to the upper floor. This is a mechanical example of accepting syntax. You also have the same situation with a programming language where in order to access your page, you need the password. And so you need a computational system that allows you to recognize the input of the password to get to the page within the website. These are examples of accepting syntax. I have automaton or system that allows to recognize specific input. And this concept of accepting syntax is also a concept that applies generally within the system of reality, so non-mechanistic transduction, so really linguistic general transduction, where components of reality are able to recognize specific input, are able to perceive specific information, because there's this accepting syntax that allows them to recognize information as produced by other systems within reality. So other components of reality are defining the evolution of the system, and some systems are able to accept the syntax that is being received, either created by themselves or created by other systems that communicate with themselves, and they are able to have a perception of that syntax and to recognize it as what it is versus what it is not. So with this syndiffeonic identification of this specific input against what this specific input is not, the logical complement. And so components within reality have accepting syntax that allows them to accept or recognize specific input, and so to have perception of specific state within reality, state that are produced by themselves, that are produced maybe by other components of reality, but reality is able to define these accepting syntax and to feed information that will be recognized by components of reality. Syndiffeonesis breaks down into sameness or synesis, which is stratified by order of relation or attribute, and difference or diffeonesis, which is a differentiative function of arity or cardinality. Every relationship, even a unary or nullary relationship, has two levels, synetic and diffeonic, with the synetic level consisting of common attributes or accepting syntactic invariance and the diffeonic level, consisting of some number of discernible instances thereof. This number being the arity of the relationship. The generic syndiffeonic relation is self-dual in the sense that its synetic and diffeonic levels are dual to each other. They are respectively associated with orthogonal axes, the synetic ordinal axis, and the diffeonic arity axis. How do we understand the similarity between the different points at the right of the origin? How do we understand the similarity between different concepts such as positive numbers and being at the right of the origin? How do we understand the existence of this point at the right of the origin compared to the logical complement of the non-existence of these points? For that, we have to break down what we see as similar and what we see as different. And what we see as similar is something that distributes over both. And so when we have a relationship, the synetic level is the common attributes of the points. For example, they're all points on the line. And the accepting syntactic invariants are what allows us to perceive those points as being there or not there. For example, there's like the space that is this accepting syntactic invariant, which allows to raise the question, is the point there or not? Are we defining the point to be there, or are we choosing not to define it? So there's this syntax that allows to perceive these two different situations. And so these represent the synetic level. And then you have the diffeonic level, which is the discernible instances. And so it's an arity being with the relationship. It was, you have the relationship and then you have different instances. So a number of arity, the number of different instances that the relationship ties together. And so these two aspects, because we're talking about syndiffeonesis, they are self-dual, they all depend on each other, and they are two orthogonal axes, so as if they're perpendicular axes. And so you have a sameness, which is an ordinal axis. It sort of stratifies the sameness below the instances. And you have the diffeonic arity axis, which is just the axis of the different instances. And so you can take those points out of the line and just put the different syndiffeonic component on these orthogonal axes, where every time we're talking about the similar things that is represented by different concepts or different instances, then we have the synetic axis, and then you can have the diffeonic arity axis, which represent all the different concepts or instances that respond to that synesis. And only through those two axes do you have the self-duality, where you are able to see the relationship. And so you are able to meaningfully represent a situation as related to the structural syntax that allows you to perceive that situation, as related to the similarity between another situation where you see the numbers as positive and you represent themselves at the right because you're aware of this synesis between the two concepts, and you are able to have these two axes, and so you're able to go further. On the one hand, you're able to synthesize the knowledge, to unite the knowledge on this ordinal axis, and on the other hand, you're able to particularize your knowledge in diffeonic instances with the arity axis. A syndiffeonic relation can be expressed in a number of ways, one of which is this. And so you have S, which is the synetic level that is ordinarily a syntax that is distributed to a more specific syntax, which are D1, D2, and D3. So there's this ordinal where S is a more global syntax than the D1, D2, D3, which are more particular syntax. And then you have the arity axis where S distributes over these D1, D2, and D3. And so it's a relationship that has an arity of at least 3 in that case, and more as well. So at least 3 instances that satisfy this relationship. And so you have the arity axis as well, this D1, D2, D3, which get embedded in a parenthesis within a synetic level of S. The diffeonic extension of the relation being just a set of things that are simultaneously recognized as different instances of the property or syntax S, which describes them, is inside the parentheses. The synetic intension, which describes or distributes over the extension, is to the left. This notation is designed to resemble an arithmetical expressions like n times a1 plus a2 plus a3 distribute as n times n1 plus n times a2 plus n times a3, and so on, in which multiplication distributes over addition. The di inside the parenthesis are the diffeonic relens, arbitrary things that are observed or conceived to differ from each other, while S is just the synetic intension or syntax, which describes or defines them. So it's exactly what we said. The synetic level distributes over the instances. And so if the synetic level is being a point on the line at the right of the origin, then each point itself is a particular identity on the line, it's a particular point at the right of the origin, but each point also carries a synetic level with it. But so you can look at each point individually, but you can also look at S as the general relation of being the accepting syntax of all the points at the right of the origin. And so this one distributes over many diffeonic relens, which are the instances in our example of the different points at the right of the origin. And so S becomes the synetic intention that is both a general relation and that is also distributed to every point within this Syndiffeonic relationship. The generic Syndiffeonic relation is self-dual in another sense as well. It has dual active and passive interpretations. It can be understood as the passive parallel or sequential assimilation of perceptual content through accepting syntax, or dually as the active, generative distribution of syntax over defined content. Generative in the sense that the content does not technically exist prior to its formative syntax. Pure cognition is virtually always generative, as it is inherently internal, subjective, and without external percepts, by which the subject can be passively imprinted. It thus describes not only passive perception, with the synetic level equating to accepting syntax through which the diffeonic instances are recognized, but the generative conatus through which instances or values are brought into being. Not only is there self-duality of syndiffeonesis in the sense that it relates the synesis S with the diffeonesis D1, D2, D3, so there's this sort of core self-duality, but there's also another self-duality that comes from the theory of reality overall and how the language of reality generate and perceive content. And in that case, the syntax S, which can be seen as perceiving, we perceive that the points at the right of the line are these points at the right of the line. And this is a syndiffeonesis, right? Because there's this synesis, this is accepting syntax. But there's also generative distribution of syntax over content. And the syntax mathematically is generated in a broader sense, but also when we see, let's say, now we see this line with this origin, this point on the whiteboard, then we perceive the whiteboard through the accepting syntax of perception. But when we conceive this whiteboard as representing this idealistic line and as this concept of maybe points that are positive. Then there's the generative syntax that distributes generatively by the cognition on the content. And so now this accepting syntax, which were like a syntax of recognizing content that is distributed to you by the system, now you understand it as something that is distributed by you to the system. So all the cognition that is subjective, internal, that rely on the human cognitive syntax, it is something that gets generated because it cannot be passively imprinted on the subject, because the subject with the internal attribute generates this syntax on the content. So when we think of the synesis and where it comes from, there is different level. There's like language has a common syntax that is distributed to every component of the language. And so they're able to recognize and perceive things and accept syntax within the system, and so are able to perceive what is inside of reality. So there's this accepting syntax that is distributed to the components of reality and that allow them to recognize what is inside reality. But there's this other aspect where the will of reality that can be expressed either globally as the source of this common syntax of reality, or locally as this adaptation of the global syntax by the language users. So there's these different levels by which we're able to understand how does this syntax emerge. Well, there's this generative conatus that becomes understood as the source of the different instances and values that are brought into being within reality. And so the syntax S is understood both as this passive ingredient that allows the system to agree on what is real and what is recognized, but there's also this active ingredient where not only the system configures what are the syntax within the system, but they're also able to make connections between different components. You can link the accepting syntax of the fact with the different networks of syntax that express more the will, the values, and so you can create this network of interconnected components of reality because you're able to generate new syntax. And so all the subjective internal aspect of cognition is a prime example of generative syntax, because it is not something that is given by the external system to the subjective cognition. Rather, subjective cognition has to generate the syntax by which it organizes perception. And so synesis is self-dual with this passive and active role of both consistently recognizing content through a common syntax that is distributed through reality, and also generative content that allows to create the connection that it needs, it wills, that maximizes the generalized utility of the system. And so this generative conatus becomes expressed as well with this syndiffeonic relation, which makes syndiffeonesis a key ingredient to explain both the structure of knowledge itself, the possibility of relating different instances within unities of syntactic ingredient, but also explains the generation, the will of the system. And so syndiffeonesis becomes a key relation to explain the structure of reality.